Hello from the Forstronics YouTube channel, and welcome to Getting Started with Arduino and the ThingSpeak Cloud. So ThingSpeak is actually more than just a cloud service. It's IoT, it's cloud and analytics in one. It has a lot of great features, and it's real easy to use. And if you're not passing a whole lot of data to it, it's absolutely free. So it's a great platform. I'm a big fan of it. They have a lot of getting started videos out there, ThingSpeak does. In this video, I hope to touch on some of the more advanced features that they have in there. Okay, let's get started. So what is ThingSpeak? I've already mentioned that it's an open IoT and cloud platform that has analytics. I believe it's made by MathWorks. And MathWorks, if you're familiar with MathWorks, they make the popular math/programming platform called Matlab. And what's great about ThingSpeak is you can actually use Matlab Analytics or Matlab Code directly in it to do post-processing and analysis of your data. And I'll show an example of that. I mentioned that it's free if you're using lower data rates, but it's pretty generous what they give you for free. They have features that allow you to react to certain data being posted and then do processing and then do visualization, so on and so forth. And I'll show examples of all that stuff. Okay, what I wanted to do for this video is look at two use models for ThingSpeak. And for this video, I'm going to be using the Arduino Maker 1000. So that, if you're not familiar with that, that has the SAM-D21 chip, which is the same chip on the Arduino Zero, but it also has Wi-Fi capability. So I'm using the Maker 1000, but the Maker 1000 leverages the Wi-Fi 101 library. So as long as you're using anything that's compatible with that library, this should work. For instance, the Wi-Fi Shield should work with this. So I mentioned I'm going to look at two use cases. The first is going to be sort of the wireless sensor network concept, where we're logging temperature data, we're storing it on the cloud, and we'll even do some post-analysis of it. And then we're going to look at more of an asynchronous real-time alerts application and basically sort of setting up a motion alarm and then doing a notification to you anywhere you are so you can tell if someone was in a room or near your house. And the idea, once again, is this is just meant to be examples. These are not meant to be full-fledged working solutions. They're just meant to be examples to help you get started. Before I dive into ThingSpeak, here is my setup. So here's the Maker 1000. And basically right here is my motion sensor. So I bought this years ago. I think I bought it, I don't know, 3 or 4 years ago, and then I never used it. So I dug it out of a drawer. And all this is really, I think it's IR based, but I'm not sure. But really all it is it has you power it up, it has a digital output that's either 0 or 1. And 1 means that it detects motion. And you can set the delay for when it resets back to 0. Okay, and then I also have the TMP36, which is a popular analog temperature sensor. It's hard to see, but it's right over here. The temperature sensor is for the sort of the wireless sensor logging, and then in the same code I have the detection of motion, just to show two examples. Okay, let's go over to ThingSpeak and check it out a bit. Okay, here we are at the introductory page, thingspeak.com. You're going to have to set up an account. I'm already logged into mine. You know, they have all different types of tutorials and things like that. I encourage you to check out. But we're just going to jump right into first looking at a channel. We're going to go to My Channels. And as I go through here, I'm going to have to blur some stuff out because some of this stuff will show my information for my channel. But what they have you do is you can create a channel, name it, and then you get certain API keys that allow you to read and write data to the channel. And if you're familiar with the font cloud, which I've shown in some of my other videos, it's similar to that concept where you have to have the secret password for it to accept the data you're writing or for you to read data from it. So I have two channels, and let's take a look at this first channel. So my channel is private. You can make your channel private or public. And so what you're looking at is data logged to my channel. Here is data from the TMP36 sensor, and here is my motion data. And I'll show my code in a bit, but basically I have motion control set up to only log when it detects movement. Here is the sensor data, and let me actually maybe expand this a little more. It has 176 readings. We're only showing 60. Let me show more. So you can see you can kind of choose how you want to display the data, and then when you scroll over it, it shows you timestamps and values. So what you're looking at here is just the raw ADC value from the A0 pin. So I'm taking that data and I'm sending it to the cloud. And then what I do next is I use one of their apps. Let me clarify a little bit what I'm talking about. The TMP36 is analog, so you measure ADC readings and then you convert them into temperature readings based on formulas and algorithms from the data sheet of the temperature sensor. So here we're looking at apps, and the first one I'm going to go to is Matlab Analysis. So here is an analysis app I created using Matlab code that's taking those raw ADC readings and turning them into useful temperature readings. Okay, so if you're not familiar with Matlab code, it's a little different from the C code in Arduino, but not too much different. Another thing different about Matlab is it's a interpreted language, meaning instead of compiling it and then running it, it actually compiles as it runs, so you don't know if there's an error until you try to run it. Another thing I'll say about Matlab is it's a high-level code, and its value is in a lot of the libraries and functions it has. It has a lot of built-in math functions, like for instance, FFTs or Fourier fast transforms, if you want to look at the frequency domain of some measurement. But it has a lot of those features built in. So that's why Matlab is very powerful for doing sort of analytics. Now, you're going to see that I have a couple things blurred out because of the fact that I'm showing my read and write keys. But what I do here is I create variables that hold my channel ID, the field. So remember, the A0 was field 1 on the channel I just showed you. And then you define also your write channel ID and your write channel API keys. Okay, so the first thing I'm doing here is I create a variable, and with Matlab, you don't have to declare what that variable is. You can just declare the variable, and it's, it has no type to it. It'll take on whatever type it needs. So here is one of their built-in functions for ThingSpeak, where ThingSpeak read, and you basically specify your channel ID, your field, which is 1 in this case, and my read API key. Then what I do is, this is a raw ADC reading, so I first turn it into a voltage. So I take the reading and I multiply it by 3.3 because the Maker 1000 is 3.3 volt device. Then, and this comes from the TMP36 data sheet, I use the algorithm they show and the voltage value to basically turn it into a temperature value. And then finally, that temperature value is in Celsius, which works in most countries, but I'm in the US, so I want to see it in Fahrenheit, so I do the calculation for Fahrenheit. This display function is really just for debugging, because it'll basically, you can test this with this output console. And then finally, then you write the data, which is very similar to the read command. So that's just a quick overview. Now, I could have done this on the Arduino, so why would you not want to do it on the Arduino? Well, first of all, let's say you have a lot of data that can slow down, if you're working with a wireless network, that can slow down your end devices on the wireless network and use their processing power up. So why not do it on the cloud, especially if you're doing some complex processes? Also, if you're working with a battery-powered device, you can look at this as a power saving. The less you're executing your CPU and the more time you're asleep, the less battery power you'll use. Okay, so that's an example of doing some of the analysis in action. Now, if we go back to my channels, what I have set up is I'm spitting the resulting readings out to this other channel called Forcetronics Temp channel. So if I go to that channel, we can see the readings, and I'm actually showing most of all the readings here. So this started in the morning. You can see it was about 72 degrees, and then it, kind of went up throughout the day. Not surprising, it warms up after the morning into the afternoon. One thing you might notice, there's a drop here, and then it pulls back up. That's because we had a quick rain shower here in Colorado, which is not surprising during the summer. But basically, that's why that temperature dropped and then it came back up. Once again, real useful for analysis and visualization. There's ways to export the data. There's ways to actually take some of their visualization tools in HTML and paste them into other types of browsers so you can use them outside of the ThingSpeak environment. Okay, let's go back to our other example where we were logging data from the motion detector. And so what we did there is we set up another app called the React app. So the React app allows you to do a reaction to some type of data. So here I basically say, I name my app, my reaction app. I say that what's the data coming in is going to be numeric. I say on data insertion, whenever a new data bit comes into the cloud, then do this reaction. And once again, I'll show you the Arduino code after this. Maybe I should have shown it first, but who cares? Anyway, so here's my channel ID. Here's my field, number 2, motion detector. And I basically say if the value is greater than 1, do this reaction. So is greater than, they give you choices here, and then you can put your own value here. So remember, the motion detector either outputs 0 volts or 3.3. So basically, when it's a 1, it detects something. And what I have it doing is I have it only write to the cloud whenever it detects motion, and then it won't write again until it goes back to 0 and then back to 1. Now, what I've set up, though, is a tweet. So I enter my Twitter account information, and then whenever this condition is met, it's going to send a tweet out. So you can think of this, I basically have this in my laboratory or office. So, I set this motion detector up, and there I can tell if anybody comes into my office by checking my Twitter account. So here's an example. So by the way, I'll plug my Twitter account here. So please follow Forcetronics at Twitter. Anyway, you can see I have a couple notifications. So this one was last night when I was playing around 24 hours. This one was this morning before I went to work. And here's another one that I did just recently before this video. One thing I'll note that I found out, though, is if you try to tweet the same tweet in too short a time, Twitter will just not put it up. So if you notice here, I changed it to a different wording. So anyway, that's obviously not ideal, but this is once again just an example. The idea here is you can have a device anywhere, detects something, some type of information or some type of sensor, and sends it up to the cloud. And then you can use the React function to basically handle it. And I should mention I chose a tweet. You can actually send out basically HTTP to some other type of web service, and you could also do Matlab analysis if you wanted based on a React. So with all that shown, let's look at the Arduino code. Okay, here is the Arduino code. You can notice I put in your network and your password. This is where you would enter your Wi-Fi network and your password. This basically tells us a status of the Wi-Fi when we're trying to connect. I create 2 client objects, one for temperature and one for motion detection. Here is the ThingSpeak server, and here is where you would put your write key. So I don't have mine there because I don't want you to see it, but that's where you would put it. Okay, here these variables are used for timing. So the temperature I check just under every 5 minutes, and then the motion detector I check every 30 seconds. But unless it's 1, and it will not log it. So if it's 0, it won't log it. Oh, pin 2 is what I use for the input of the motion detector. It's just a digital pin, so I'm reading 0 or 1. And then I configure pin 6 because it's the LED pin. First, I do my connection, and I keep looping until I connect. And then in my main loop, all I do is I have 2 timer functions. So the loop's going around, and when the temperature timer ticks out, which is for some minutes, first I put the LED on, and then I call this function, which I'll show, basically sending the right strings out to the ThingSpeak cloud so we can post the data. I then shut off the LED. Similar thing here, except it happens every 30 seconds. and I have an if statement here. So I basically say if digital pin 2 is high and if reset is true, then basically turn reset false and send out the high condition to the cloud. Now remember, if the cloud gets the high condition, it's then going to trigger the React app, and the React app is going to send out the Twitter notification. And the reason I have this boolean in here is because I don't want it to keep sending it out if that same motion is being detected over and over. So what I do is I wait for it to go low again before I reset this. This way I'm ensuring that I'm not sending out a tweet every 30 seconds. Now, here is the function for temperature. So I'm just doing an analog read. And I basically got all these strings from one of the ThingSpeak examples, but you're basically building a bunch of strings to communicate with their server over port 80. And you can see here's my API key. Here's where I'm adding the sensor value. Then we send it off, and then we want to make sure we close the client connection, and then we reset our timer. Very similar thing here to the motion detector. We build our strings, and we send our data. As I do for all my videos, I'm going to post the code from the sketch as well as the Matlab Analysis code on my blog. And I'll have a link for my blog in the video description. Okay, that's it for getting started with Arduino and the ThingSpeak Cloud. If you have any comments to share related to your ThingSpeak experience, please share them in the comment section. If you haven't already, please subscribe to the Forstronics YouTube channel. And if you need any help with a project, turning it into a commercial or entrepreneurial endeavor, please check out my contracting services. We also now are doing small-scale manufacturing of electronic PCB and assembly. Anyway, thank you for watching.